Have you ever looked at a packet of table salt and noticed the small label NaCl? What does it mean? Well, that's a chemical formula, a symbolic way to represent what a substance is made of. A chemical formula tells us how many atoms of each element are present in a compound. For example, water is written as H2O, which means it contains 2 hydrogen atoms and 1 oxygen atom. These formulas are more than just symbols, they help chemists write reactions, balance equations, and understand the very building blocks of matter. But how do we decide what goes in a formula? That's where the concept of valency comes in. Think of valency as the number of arms an atom has to bond with other atoms, just like how Lego pieces can connect only in certain ways. Valency tells us how many bonds an atom can form. For instance, hydrogen has a valency of 1, oxygen has 2, and aluminium has 3. Atoms or groups of atoms that carry a charge are called ions. A positive ion, like sodium, written as Na+, a negative ion, like chloride, written as Cl-. We even have polyatomic ions, like ammonium, NH4+, sulfate, SO4 2-. So how do we use valency to write a chemical formula? There are a few simple rules. First, make sure the total positive and negative charges balance out. Second, for compounds with a metal and a non-metal, the metal is written first, like in sodium chloride, written as NaCl. Third, if a polyatomic ion appears more than once, use brackets. For example, calcium hydroxide is written as Ca open bracket OH close bracket 2. Finally, we apply the crisscross method where the valency of one ion becomes the subscript of the other. Let's try this in action in the next scene. Let's begin with hydrogen chloride. Hydrogen has a valency of 1. Chlorine also has a valency of 1. Since the valencies are equal, we simply write HCl. Now let's try hydrogen sulfide. Hydrogen is equal to valency 1, sulfur is equal to valency 2. We apply the crisscross method. Hydrogen becomes subscript to sulfur becomes subscript 1, which is usually not written, so the formula becomes H2S. It's that easy. Know the valency, crisscross, and write the formula. Now let's walk through a slightly trickier example, magnesium chloride. Step 1. Write the symbols. Magnesium is Mg, chloride is Cl. Step 2. Know the valency. Magnesium has a valency of 2, chlorine has a valency of 1. Step 3. Apply crisscross. Magnesium subscript becomes 1, chlorine subscript becomes 2. So we write the formula as MgCl2. This means 1 magnesium atom bonds with 2 chlorine atoms. Let's now look at compounds with polyatomic ions. These are groups of atoms that behave as a unit. Take calcium hydroxide as an example. Calcium is Ca2+, hydroxide is OH-. To balance the charges, we need 2 hydroxide ions for every 1 calcium. So we write the formula as Ca open bracket OH close bracket 2. Why the brackets? Because we are showing that the entire OH group appears twice, not just the H. One more example, ammonium sulfate. Ammonium is NH4+, sulfate is SO4 2-. To balance, we need 2 ammonium ions per sulfate ion. Final formula, open bracket NH for close bracket 2 SO for brackets help us avoid confusion and keep the structure clear. Let's quickly revise what we've learned about writing chemical formulae. Chemical formulae show us which atoms are in a compound and how many of each. To write them correctly, we must know the valency of each ion, balance the positive and negative charges, use the crisscross method, apply brackets when needed for polyatomic ions, whether it's water H2O or calcium hydroxide. These formulas help us understand and predict chemical reactions. I hope today's session helped you turn chemical symbols into meaningful formulas, because chemistry starts here. one atom at a time. Catch you in the next class with more molecule mastery and formula fun.